Well, welcome. I am Mr. Murphy, and in this particular video, we are looking at our very first skill of many. This is power skill number 1. And in this particular skill, we're going to be looking at how to find the domain of a function when it's given to us symbolically, meaning given it to us as an equation. We're going to be finding the domain for that function. And before we get started, there's going to be some terms that we're going to look at to make sure that you understand what we're even talking about to begin with. But before we even get to that, let's look at some examples so you know what our goal is as far as the problems that you'll be working with on your own. So here's some examples, like I said, of these we'll be looking at here in a little bit on your own. Here we're looking at the first function. You're taking 6 divided by x squared plus 25, and you'll be trying to find what is the domain for that function, or g of x equals negative 3 divided by 2x plus 4. What is the domain for that function? And these will be ones we'll be looking at here in a little bit. But first, before we try to figure out what the domain is, let's first figure out, well, what is a function and what is a domain, so you know what we're even talking about here. So, what is a function? Well, a function is defined here as an equation where each input value results in a unique output value. Now, if you notice, we have this function f of x equals 2x plus 9. Now, that piece at the very beginning there, the f of x, that's just naming the function. We could name a function using any letter. We could say function f, function g, function h. Those are the 3 most common letters that we use to identify a function. But if we're dealing with a function involving temperature, you could use T for temperature. If you're dealing with someone's name like Samantha, you could use S for a function, or whatever letter you want to use to name the function. The other thing to not be concerned about is sometimes people see function f for one example and then function f listed again, and function f now will look completely different from the first function f. Again, don't get hung up on that. Just because, for example, if you meet someone by the name of Steve and meet someone else by the name of Steve, that wouldn't confuse you, thinking that, oh my goodness, how could I have 2 people with the same name and look completely different? Same thing is true with these functions. We name them, sometimes we'll see multiple equations with the same name of function f. But you can't get hung up on the fact that they're the same letter, that we're naming them the same thing, but yet they mean something different in every example. It's like I said, it's the same as naming someone or seeing someone with the same name in your class. So that's the name of the function, f of x. Now what's in parentheses there following that f is our input value. So in this case here at this example, our input value is going to be x. To the left, the equal sign tells you what you do with that input value. So here it's telling us that we're going to take with that input value, we're going to multiply it by 2 and then add 9. And by doing that, that would give us your output. Now the domain of a function is given to us down here. The domain for a function defined as the set of all possible input values, meaning usually it's going to be your x's, the numbers we can put in for x, which produce a valid output from a particular function. So looking at the example here, the f of x equals 2x plus 9. If you think about that, you can put any number you want in for x. I can put negative numbers in for x. There's nothing keep holding me back from doing that. I could put 0 in there for x. I could put decimals. I could put really large numbers. I could put really small numbers. I could put fractions. Any real number you can think of, you can put in there for x. So that would your domain. That's how your domain would be, all real numbers. Now, how do we write that? What do we put as our answer? Well, one of the ways that we can write our answer is using what's called set builder notation. What's set builder notation, you ask? Good question. So here's how we write our domain, like I said, using set builder notation. So for that f of x equals 2x plus 9, the way that we'd write that your domain would be all real numbers is like this. So here's how we do it. Set builder notation. The reason why we call it set builder notation is we're writing our answer as a set of numbers. And we identify a set using those little brackets. So we start with the bracket on one side and end with, close it off with a bracket on the other side. And since our domain is dealing with our numbers from the x's, we would start out saying that our set is we're taking that from our set of x's, such that, that's what that vertical line means. It's not an absolute value symbol. That vertical line means such that. You can also use a colon, 2 dots above each other. That also means such that. Such that it's going to be all real numbers. So we just write in the word all real numbers as your answer. So that's how we use it dealing with set builder notation. Now, it's not going to be always all real numbers. Sometimes there's going to be some restrictions on our domain, some values that we can't use in our domain. For example, here we have f of x equals 4 divided by x. If you think about your rules of math, we can never divide by 0. So x could be any number. X could be negative numbers, positive numbers, decimals, even fractions. X can be any number. The only thing that x cannot be is 0, because you can't divide by 0. So here's how we would define it, is that you could have the set of x's such that it's going to be all real numbers except x cannot equal 0. So that's one way that you could write it. There's other ways you could write it, but this is just one. Okay, let's look at those examples that we talked about earlier. We're going to do this first one together, f of x equals x squared plus 25. And then you're going to do the one above me here, function g. You're going to do that one by yourself, negative 3 divided by 2x plus 4. Again, we're finding the domain here. So let's look at the first one on the left. Well, actually, that first one on your left, I just realized there was a typo there. It should have been in the denominator x squared minus 25. So I've already made that change. So you want to make sure you make that change yourself. But we have 6 divided by x squared minus 25. So again, you cannot have 0 in the denominator. So I want to figure out what value or what values for x we couldn't have in the denominator where it would end up giving us 0 down there, because again, you can't divide by 0. So the way that I'm going to do that is I'm going to start out by setting this up, x squared minus 25, and setting it equal to 0, because it's what we don't want in our denominator is 0. So I would start by adding 25 to both sides, giving me x squared equals 25. And now that I have that, I'm going to take the square root of both sides, which gives me 5. However, there is more than one value that x could be here, because yes, 5 squared does give me 25. But can you think of another value that I could square that would also give me 25? Well, maybe you've thought of it. Negative 5. Negative 5 squared would also give me 25 as my answer. So there's two things that x cannot be. X can't be 5 and x can't be negative 5. Because if I square 5, I'd have 25, and 25 minus 25 would give me 0, which I wouldn't be able to do. If my value for x was negative 5, if I squared negative 5, negative 5 squared would be 25, and 25 minus 25 would also be 0. So the way that we would write our answer using set builder notation would look like this. We'd say the domain would be the set of all x's, such that we can say x cannot equal positive or negative 5. That's how you could write your answer. So you technically don't have to write down the words all real numbers. If you want to include all real numbers except x cannot equal positive or negative 5, that would be fine. But you could also write it this way. Set of all x's such that x cannot equal 5 or negative 5. So why don't you guys try this next one on your own. And so why don't you pause the video at this point and hit play when you're ready to check to see if your answer is correct. Okay, so let's see how we did. So you should have done this. Again, we can't divide by 0. It doesn't matter what the numerator is, it's just that the denominator can't be 0. So I want to figure out, well, what would x have to be to give me 0? So if I start by subtracting 4 from both sides, I end up with 2x equals negative 4. And now, if I divide both sides by 2, I get x equals negative 2. So if you think about it, this would be the one value that x couldn't be, because if I put negative 2 in my equation, 2 times negative 2 is negative 4, and negative 4 plus 4, sure enough, gives me 0, which is what you don't want. So my answer, written in set builder notation, would be this. It's a set of all x's such that x cannot equal negative 2. And that would be your answer. Well, there you have it. This is skill number 1. Hopefully after watching this video you have a better understanding of how to find the domain when you're looking at a function symbolically. So with that, good luck as you try some of these now on your own.